Okay, today we're going to talk about the addition and the subtraction postulate. We use these when we get not an entire length of a side of a triangle or not an entire angle of a triangle. So we use what's called the addition or the subtraction postulates when we're given part of a side and we want to add something to it to make it an actual side of the triangle. So if we look at the basics of it, if we are given that AB, so from A to B, this piece here, is congruent to CD, that's given to me. I want to prove that AC, so from here to here, is congruent to BD. If we notice, in order to get AC, we need to add to that BC. Then I would have the entire length of AC. And if I look, if I added BC to CD, I would get the entire length BD. So in order to put that in a proof, step 2, since both pieces want BC added to it, we're going to say that BC is congruent to itself. That, from the other day, is called the reflexive property. Now, I want to prove that AC and BD are equal, so if I take what's given to me, that AB plus BC is congruent to CD plus BC, if I add them together, AB plus BC, I get AC congruent to BD. That is called the addition postulate because I added something to something smaller, and that's how we put it in our proof. Now, if I look at the second example, it says given that AC, so this whole piece here, is congruent to BD, this whole piece here. I want to prove that AB, this piece here, is congruent to CD, this piece here. So if I notice, since the two blue pieces are equal, the overlap, or what they're sharing, is BC. So once again, in my proof, I'm going to write that BC is congruent to itself by the reflexive property, and then because I want to get rid of BC so that I'm left with AB and CD, what I'm going to write is AC minus BC is congruent to BD minus BC. Since I'm subtracting, I'm going to call that the subtraction postulate. And over here, when I minus AC, this piece here, and I minus BC, the middle piece, I'm left with AB. And when I do BD, the whole segment, minus BC, I'm left with CD. Now we're going to apply this rule to an actual proof. So now if I look at this proof, it says prove that triangle ABC is congruent to triangle FED. So if I look, I have triangle ABC, which is up at the top, and FED is at the bottom. So once again, when I'm starting to do my proof, I always start with part of the given information. Angle A is congruent to angle F. That gives me an angle for each of the triangles, so I put an A. The second thing says that angle B is congruent to angle E. This is given. This is given, and you could write them in one giant step if you wanted to. If I mark angle B and angle E, that also gives me an angle. Now the third part here says that EC is congruent to BD. So EC, I'm going to get a different colored pen here is congruent to BD, this piece here. Now if we notice, and that's given also, That's not an entire side. It's part of a side of each of those triangles. However, if to side EC, if I look at this, if I add this middle chunk, then I would end up with this entire side of the bottom triangle and this entire side of the top triangle. So to put that in the proof, because step 3 here is not a complete side, I'm going to say that CD is congruent to itself by the reflexive property. And then I'm going to add, so it's kind of lined up in the proof for me. If I add steps 3 and 4, EC plus CD is congruent to BD plus CD. So if I add them, EC plus CD is going to give me ED. And if I add BD and CD, I get BC or CB. And that is my addition postulate. Now again, I said they're lined up in the proof. If you look at this, if I add these two here, that's what I wrote here. If I add this one and this one, that's what I wrote here. So now this here, where this gives me an actual side of my triangle. So now if I look going down the left column, I have an angle, and a side. That's enough information to say the triangles are congruent. I'm going to look at my picture, and looking at my picture, I see I have an angle here, and then I have this side. So the two triangles are proven congruent by angle, side. Remember, it's not how the angles and the sides appear going down this column. This is for you to know if you have the 3 pieces of information you need. It's how it shows up in the picture. And in the picture, it's angle, side, congruent to angle, side. Now, if we look at the next one, it says prove triangle BEA is congruent to triangle DCA. So we can clearly see those two triangles. So the first thing that I'm going to write down is part of the givens. And again, some kids like to write all the givens in the first step. Some kids like to do it one at a time. It does not matter which way you do it. Now it says angle BAC. So if I look, angle BAC is congruent to angle DAE. D to A to E. Now if we look at those, that's not an angle in our triangle, it's too much. But if I look at the picture, hopefully you realize if I take away angle 2 from the red angle, I'm left with angle 1, which is in a triangle. If I take away angle 2 from the blue angle, I'm left with angle 3, which is in the triangle. So I am going to say in step 2, angle 2 is congruent to itself by the reflexive property. Then I'm going to say angle BAC minus angle 2 is congruent to angle DAE minus angle 2. So, and again, there's numbers there, so we don't even have to use letters. Angle 1 is congruent to angle 3. Because I took away the extra, that's called the subtraction postulate. That gives me an angle in each of the triangles. I'm going to mark it, angle there and an angle there. I used this step, so I put a little X. And I used this step, so I put a little X. Now again, I'm going back to grab more givens. If you wanted to, originally in step 1, you could have written all 3 lines there. So for number 4, I'm going to say that AE is congruent to AC. That's given. So AE, AC. That gives me a side on my triangles. That's given. And then I'm going to get the other piece of given information. A is the midpoint of BD. So if I look at my picture, if A is the midpoint of BD, that means it cuts it in half, right? So I'm going to say that side is equal to that side. So my step 5 is going to be that BA is congruent to AD, and the reason is a midpoint cuts a segment into two congruent pieces. That gave me a side of each of my triangles. Once again, I'm going to look going down the left column of my proof. I have an angle, a side, and a side. That's 3 things. That's enough to prove they're congruent. But notice it spells a bad word, so we're going to look at the picture. And looking at the picture, I have a side, an angle, and a side. And on this triangle, I also have a side, an angle, and a side. So I can say that triangle BEA is congruent to triangle DCA, and the reason, side, angle, side, congruent, side, angle, side. Please make sure that you write down any questions that you might have and ask me next time you see me in class or send me an email. Thank you.